Willkommen, bienvenue, and welcome back to the Modding of Isaac with Lyte. In today's episode, we're going to cover some very basic shaders. Shaders can do really cool and powerful things, but they're significantly different from the way we do things in Lua, so this first episode, just gonna take it really easy. So we're gonna start ourselves a new run. Might as well use Samson because, well, the shader that I'm working with this time actually has to do with your current health. And Samson is one who does enjoy modifying his health. And so, what happens when we're like, hey, maybe we want some more damage? Ah! Did you see it get a bit less saturated in here? All of the colors seem a little more washed out. Well, that's what the code we're working with today does. That as you take damage, it gets more and more washed out until you get down to half a heart, at which point it is super washed out. It's still a little bit colored. It's still not white, but it has lost a lot of its color. And so, we haven't done anything to the sprites. We don't know anything about them when we're making these changes. All we're doing is, on a pixel level, deciding how we should actually render it, as opposed to how the game thinks we should render it. And so this particular shader, it doesn't really care about what else is going on the screen. It doesn't really care about where it is on the screen. It just treats every pixel the same, and with a little bit of input from the game itself, it decides at what point it should make it super unsaturated or otherwise. So let's head over into the code. We'll look at how you make the shaders, and we'll look into just general sorts of shadery type things. So, this particular topic does require a content folder and main.lua. In the content folder, you need shaders.xml. You'll also want the documentation for this, because it's got a good section, and I copied the vast majority of the code from here, adapted it just a tiny little bit to make it do what you saw in the example. Now let's zoom on in on this such that it's more readable at home, and we'll walk you through what's here, just in case this doesn't make a whole lot of sense to you. So you need shaders.xml, spelled exactly that way, in your content folder, not resources, in your mod, such that it'll work. I already showed you that part. So the XML has this structure. Well, if you haven't worked with XML a whole lot, it might be a little scary, but we've worked with items.xml, we've worked with players.xml. It should make quite a bit of sense to you, except for a couple of weird things. Like this CData thing with the exclamation point. A lot of that you're just gonna take on faith. You can have more than one shader. You just need to give them different names. And within them, you have a vertex shader and a fragment shader. We're not going to get into the details of what each of those means. But for today, the vertex gets the information from the game and passes it on to the fragment. There are parameters that you can send in. That's anything from the game that you want to tell it. In my case, I just tell it how desaturated I want it to be. Of various types. Float, which is just a number. Vec2, which is two numbers squished together. Vec3, three numbers. Vec4, four numbers. So for example, a color is a Vec4. Because you need red, green, blue, and alpha. Four things. And so you need all of these. The game passes those in. All of this is done for the game. Then you've got your attributes, things that you pass on in and transform for doing fancy things. Then the Fragment Shader has a few extra things, but these will all match something up here. So color, color 0, text chord 0, render data out, scale out, and then one little extra, texture 0, which is what we're looking at. Render data gives you some useful information that we will use in future episodes if we do more with shaders, because there's one I have in mind that could be really fun. But you need to know the window size or the texture size, such that if you want to do things around the edge of the screen, you know where the edge of the screen even is. And then scale, which we ran into in the past with trying to do the mouse stuff. When you have it in windowed mode, it'll scale differently depending on the size of your window. And so here is a complete shaders.xml file where it calls at random colors, passes in the player's position and the time, uses that here, passes it along here. Here's void main. This is the actual code for the shader to do things. Well, all of these outs are for passing it along to the Fragment Shader. Whereas GL position, not 100% on that, but I have a feeling it tells it where to do what it needs to do. Then in the fragment, the real magic happens. The Fragment Shader is where you grab the color from the texture. So the texture is what is on the screen. At least what's supposed to be on the screen. So it grabs the texture, grabs the text chord, which is the coordinate on the texture. Where in the image are we looking? And then we apply changes to the red, the green, and the blue. In this case, where the player is, and a sine wave of the time. So it goes all wibbly wobbly on you. So we replace all of this with what we actually want to do. We swap out player pause and time for the attributes we want to talk about. And then here's the Lua. Very simple. One simple callback to get shader params. It gives you the name, and then you give it the parameters. Now, if you had multiple shaders, you would check which shader it's asking about and give it the appropriate parameters. Since we only have one, it doesn't really matter. You just hand it what you want. But if you had more than one, you'd want to have some if statements and give it only the things it really needs to know. So let's actually look at the code that I used. So main.lua is incredibly simple. It's got that callback, get shader params, on shader params, here are my shader params and my shader name. We get the player because something about the player is interesting for our shader. And then the amount of the saturation or desaturation is the minimum of 1 or their hearts plus their soul hearts divided by 6. Such that if they have 3 hearts, which just start off the game right out of the bat, if they've got those 3, they're fine. Because 3 full hearts is 6 hearts in the code, and that'll be 1. The min of 1 and 1 is 1. If they've got more than that, say they've got 12 hearts, oh, that's a whole lot. That's way more than 1. The min is 1. But when you start dropping down to 5, 4, 3, once you're at 3, you're at 1/2. It's less than 1, so that's what we send to the amount. And so it gets closer and closer to 0. So what this is measuring is the saturation of the color on the screen that we want. So we're telling it how saturated to be. Between 0, which is completely desaturated, and 1, which is as saturated as it wants to be. So now we head over to the shaders and make that work its magic. So we name the shader something. I called it Seeing Red for that future project. Then we have the parameters. Remind you, I got all of this code from the documentation. I just changed a little bit. You can do the same exact thing. You update the parameters. So we have a param, its name is amount, to match this right here. We have a param, named amount. You put it in the curly braces, you give it a name. This name has to match this name, which has to match this name. Which type? It's a float. It's just a number. It's not a vector with 2 or 3 or 4. It's just a number between 0 and 1. So all of these are mandatory. You leave them alone. This one is our attribute. It's a float called amount. Float called amount. Now we have a varying float amount out. This is for passing it along to the fragment shader. So you do one that's an attribute, one that's varying that we pass along. And then void main, void. You keep these the same for passing along to the fragment shader. You keep this the same for passing along. This is your custom one. Amount out equals amount. So amount is what we got from the code. Amount out is what we're sending over to the fragment shader. So to this point, we haven't actually done anything but pass along data. Pass it along, pass it along, pass it along. Now, the magic. Here, we've added our amount out, a varying medium precision float. I don't know how much precision we need, so I left it with what they had for the player position. But it'll give us a number between 0 and 1. Here, we get the color of the pixel that we are looking at. It's a vec4, red, green, blue, alpha. And then I compute a value of gray from that. We take our red, multiply it by a constant, green by a constant, blue by a constant. Now, you could just divide them by 3 and get an average value, but it doesn't really correspond well with how people actually see color. I'm not a huge fan of these either. These tend to make it feel washed out to me as well. If I were to make a true grayscale filter, I wouldn't do it like this. But this is quick and easy. I personally would want deeper shadows. So if we go back to Isaac, if you look at this, it's really washed out. The shadows don't seem as deep to me as they do when the colors are there. So personally, I would make a different one in the end. But for the sake of getting something done and running, we can use this for a vaguely psychometric gray value. And then we get a mix of that gray. So you just set the red, the green, and the blue all to that same value, because gray is all the colors are the same. This here is determining the intensity of the color. And this is the balance of red, green, and blue in how you're supposed to feel the intensity. So here's gray. Here's our original color. So color 0 times texture at that point. So we get a color that we can work with. We mix it between gray and that color, balanced out by the amount that we passed in. So we have completely desaturated, completely saturated, and what percentage of each to do this mix. Now this mix is a linear interpolation. If you like those words, linear interpolation, that's what we're doing. We're taking one and the other and going somewhere in between. So if it's 0, 1, and 0.7, then we get 0.7 because it goes part way from one to the other. And I can go more into linear interpolation if you really, really care about it, but basically, we've got one side, we've got the other side, and we've got how much to mix the two. So that's all it takes to make this decreasing health grayscale shader. But this is not the only thing you can do with shaders, because you don't have to just work with that pixel, because since you've got the coordinate and the texture, you can look at some things around it to make it all wibbly wobbly. You could, instead of just making it gray, you could take the saturation and figure out some other vibrance for it. So if it's already saturated, don't do much, but if it's fully desaturated, maybe give it some more color. You could make it sepia. You could do pretty much any Instagram filter you want using shaders. It's a really powerful thing, but I'm not super familiar with it, so I'm learning here along with you. But this at least gets you started. Just getting information into your shader from the game itself, passing information along, and then modifying the color to do what you want it to do. Also, from this render data out, you also have the window size and the texture size, such that you can have it work only on part of the screen, which is particularly useful if you want to, say, have a gravity warping effect like with the Void Portal, or some sort of other kablamo effect with a shockwave, or if you want one of your enemies to bleach the color out of the surrounding areas. That should all be possible in here. Now, how that's going to happen, I make no guarantees, but it should be possible. But for now, we've just got ourselves a nice, simple shader with a linear interpolation, figuring out the gray intensity, passing some information along from this fancy callback. That's all I've got for this episode. I will see you in the next episode of the Modding of Isaac with Lyte.